Welcome to Math 1324. Today we're looking at section 2.1. We begin looking at something called a function. A function simply takes a collection of inputs into the function. The function does something and it spits out some outputs. The domain is the collection of inputs we can use, and the range is the stuff that comes out. To be a function, there's only one requirement, and that is each input can only produce one output. So they give us a graph here, a table. And so what I'm seeing is 3 produces an output of 2. 6 produces an output of 2, so does 4, and so does 12. So you just ask yourself, does each input only produce one thing? And the answer is yes. Therefore, this is a function. If I'm looking at the second question here, what I see is minus 7. That input produces an output of 11. That's good. So from these first two numbers, there's only one arrow going away from the number. But looking here at minus 12, there are 2 arrows going away. So minus 12 is producing more than one output, so this is not a function. In question 3, we have a graph, and in this graph, they're going to ask us, is this the graph of a function? Well, how do we know? There's something called the vertical line test. Draw every possible vertical line. If each vertical line only crosses the graph in one place each time, then that is a function. If it crosses multiple times, then it's not a function. So in this example I drew here, this vertical line would touch the graph in more than one place, and so it's not a function. Whereas this one only crosses once each time, so yes, it is a function. Let's see. Not sure why that PDF is not cooperating. Alright, that looks better. Alright, so let's scroll up here. Alright, so in this case, we have a little circle or ellipse. If I draw the vertical line here, it crosses in 2 places, so it's not a function. Alright, in question 5, we begin to look deeper at graphs. This axis, the x-axis, that's typically where inputs come from. The outputs are here on the y-axis. Now you might think, well, the dot on the graph is the output. No, the dot on the output, in this case, which is 1, 4, this dot represents the input and the output. So what you're looking at is come here to 1, go find the graph, whatever height that is, and head back to the y-axis to actually find the corresponding output. So what about over here? If I picked an input here, I'd have to go down and find the graph and then head back to the y-axis. But the x-axis is where the inputs are. The outputs live on the y-axis. and the dots that live on the graph combine the two, input, comma, output. All right, and in question 6, we have a graph again. We have a input here of 4, so that's the input. The question is, what happens when I put in that input? Now, it's a bit difficult to see from the small graph, but on the homework, they do let you zoom into the graph so it's easier to see. So if I picked 4, I gotta have to go find the graph. Well, I can't go up and find it. I come down to find it, back to the y-axis, making the output minus 4. Now in question 7, they change things up a little bit, and the question is f of x equals 3. The question is, what inputs are going to produce an output of 3? So since I'm curious about an output of 3, I draw me a line on the output of 3, and I look, does that touch the graph somewhere? Yes, right here. And then if I backtrack, go back down to where the input came from, I see that that particular input is 3. Okay, so when they change it up, you have to go to the output axis and then backtrack. Okay, let's see. And here on question 8, the question is, what inputs produce an output of 0? Okay, so here's my output of 0. All right, but I notice that that's crossing this little graph that you probably barely can see. Let's see if we can zoom in a little bit and still let you see it, maybe. All right, so looking at that, I see there are 1, 2, 3 values that give an output of 0, and they are at minus 2, 0, and 7. All right. In question 9, they're going to give us a function. So here's our function. And the question is, what inputs can I use? Now that seems like a complicated question, but it really boils down to only 2 problem areas. We can't have 0 in a denominator, because if I have a number divided by 0, that's undefined. Similarly, I can't have negatives under even-rooted radicals, because if I had a square root of a negative number, that would mean it's a complex number. So in our case, I look at this function and I'm asking myself, does it have a denominator or radical? No. Therefore, the domain is all real numbers. Whereas here in problem 10, it does have a denominator, and I cannot have that thing be equal to 0. So let's see, when would that happen? Well, x plus 4 is 0. That would mean x is minus 4. So I cannot have minus 4 in my domain, so I remove it. But it's the only number that makes it 0, so I can use everything else. And they wrote it this way, all real numbers except minus 4. You could also write this in interval notation. I've got this little branch on the left, which is minus infinity to minus 4 with a parenthesis. It's a parenthesis because of an open dot. I've got this branch on the right, which would be minus 4 to infinity, infinities always get parentheses. And since I have two branches, I would have this U in the middle for union. That would be in interval notation. They just wrote it as everything except minus 4. All right, question 11. I see that I've got a radical and some stuff under it. I don't want this stuff to be negative because the square root of a negative number is a complex number, and we only want real numbers to come out. So I want to make sure the stuff under the radical here calculates to be greater than or equal to 0. So I move the x, so 7 is greater than or equal to x. Because of the equal, this is a closed dot on the 7. Now you might think, well, the inequality points to the right, so it's going to be everything bigger than 7. But that's just not true, because take a test number like 8. Is it true that 7 is greater than or equal to 8? No. But if you pick the test value over here, such as 6, is 7 greater than or equal to 6? Yes. Therefore, it's everything under 7. 7 is a closed dot because of the equal, so I get a bracket, and it's everything off to the left forever. All right, question 12. In question 12, we have again this thing of I have a function, and it looks like f of an input is that input squared minus 2. The x is simply a placeholder for the word input. So they want us to plug in 5x as an input. All right, no problem. Just fill it in everywhere I see the word input. Now this would be 5x, that thing, squared, which is 5x times 5x, which is 25x squared. Easy enough. What about if we wanted to plug in 4 plus h? Well, replace your x's with blanks. That way you know exactly where to fill in the thing in question. So I'm filling in 4 plus h. So it's 4 plus h, that thing, all of it squared minus 2. So let's see, 4 plus h squared really means 4 plus h times 4 plus h. So grinding it out, 4 times 4, 16. 4 times h, a 4h. Another 4h. H times h is h squared. But let's not forget this minus 2 on the end. And if you clean this up, you get h squared. I've got 2 of these 4h guys, so 8h. And then 16 minus 2 is 14. All right, question 14. We have a function, so f of blank is 4 times blank minus 3. So they want us to plug in x plus h. So I simply plug it into the blank, grind out. So I've got 4x, 4h minus 3. Part B, they say take f of x plus h and subtract f of x. All right, so here it is. So I just fill in parentheses my answer to the first part, minus, and now I just simply fill in what is f of x. F of x they gave us was 4x minus 3. Take care of the minus, distributing it in. So I get a minus 4x, and I'd get a plus 3. And then we look to see what cancels, and what cancels is the 4x, the 3, and I'm left with a 4h. In the last part, we simply take the 4h over h, and we get an answer of 4. And in our last problem, it's kind of a word problem, but we want to express this as a function. So I have the perimeter of a rectangle. Okay, so first off, let's draw our rectangle. Our rectangle has lengths and widths. Well, how do I get the perimeter? Well, the perimeter is the length all the way around. So the perimeter is W plus W, so 2W, plus L is 2L. So here's my perimeter. And they said it's 320, so I could fill that in. Divide everything by 2, so it looks a little bit cleaner. So now hold that thought. They also say express the area as a function of length. Well, what's area of a rectangle? It's the length times the width. They want me to write a formula for A with only the length. So I take this thing right here that we had with the perimeter. I solve it for W. So W is 160 minus L. And if I plug that in, I get my formula for the area. And my formula for the area is L times 160 minus L. So there's my function. That's all we need. Now, what's the domain of this? Well, don't be petrified. First off, it's a real rectangle. So it's a real rectangle. The length can't be 0. That makes sense. And we've got the width is 160 minus L. So my width can't be 0. So L can't be 160 either. So my length L is stuck in between 0 and 160.